is September the 15th, 2022, and today we are looking at testing my Maxton XT2190 hard drive. Now, this is a very special hard drive to me because it's one of the largest capacity hard drives that I've ever owned with the MFM hard drive interface. This disk has only been powered on for about, I guess, less than 4 hours. I'm saying that because it was only powered on to image the drive, and the drive was bought as part of a Comenco CS200 unit, which I dismantled to use for parts for other Comenco systems. So when I got the actual CS200 system, I took it apart. I've used all the cards in other places, and the hard drive was imaged. And the reason it was imaged is because it contains the wonderful Comenco Unix 5.2 operating system, which is pretty rare, I would say. That does require a memory manager. It also contains the Chromix version 172XXU, as I call it, which is the special version of Chromix for the 68020 processor. So two very rare bits of software are also stored on this disk, but they've been imaged for posterity. In front of you, you see the disk info screen. So if we run the disk info command on device STD31, you'll see that we've got an enormous 1,225 cylinders. There are 15 data heads, so there are 8 platters, and one of the surfaces is used for servo and tracking, as I understand. So this disk is partitioned for Comenco systems. You can see there that's the partition table. You can also see it's got an alternate track table. Now what's that about? So disks at the time, and still today, are not error free. And so in the olden days, it was our job within the operating system to remap the actual good and bad tracks. So we've got a hard drive table which indicates on the front of the physical disk, indicating what tracks and surfaces are bad, and so we've entered that, well, Comenco has entered that into the alternate track table for the drive. Okay, so we're going to start the read all command, and the read all command is going to read every byte from every sector of every track of every cylinder of the disk, and we're going to compare that and see what the results are. Read all slash, oh, I don't need to put the slash STD31. Let's go. This is going to take a while. So let's begin. So you'll see, according to the alternate track table, cylinder 43 head 6 has got an error. Okay, so there's one more error that's not listed, that's shown up. That's cylinder 23 surface 5. Let's just check the cylinder 43 error. We should see in a second. Okay, so that did not show up. So in other words, there's a mapping of cylinder 43 head 6 here, and that's mapped to cylinder 1200 head 5, but that's not actually shown up as an error. So what I would do if I was reusing this disk for real is I would probably reinitialize the whole hard drive, and then on that reinitialized disk, after using the init command, the init hard command, I would run the same command again and find out what sectors, sorry, what tracks and on what cylinders are actually in error. So I suspect there will be less errors than I've shown, because this is a very large number of errors, and I believe that the actual errors on the drive will be less than this. So we've got one now, and we're at cylinder 112. We're going to get to 148, and then I really am going to shut up. Close. Okay, we've got cylinder 1, 2, 3 as well, surface 11. Yeah, so you can see that in the last 30 years, the good and badness of this disk has changed slightly. I would reformat the disk. I often find that when I reinitialise the drive, I get a clean result. So I'd let the drive spin for a few hours, I'd reinitialise the drive, I'd run the read all command, and then remap this, well, I'd delete the entire alternate track table and start from scratch. Alright, let's continue up to cylinder 1, 2, 2, 4, counting from 0. Okay, Darry, so we have finished the read-all testing. You can see that there are a number of primitive read errors on this hard drive, and let's see if they correspond to the actual ones that Kremenko put into the alternate track table back in the day. So you see we've got just random example, surface 14, cylinder 441, and look what Kremenko's put in. Yeah, they've got cylinder 441, head 14, and that's remapped to cylinder 1201, head 0. So in other words, when the operating system was told to seek to cylinder 441, head 14, and read and write something, it would instead jump to 1201, head 0. And all that's done in software because the drive itself doesn't know anything about its good and bad sectors. So back in the day, so we're talking around about 1990, and these hard drives first came out about 1984, 1985, something like that. Back in the day, it was the operating system's job to do all of this remapping. So that's why there's an alternate track table which is written onto the hard drive, and it's read by the operating system on boot, and then the operating system does this remapping. And it does this remapping because I will have done an initialization of the drive, I will have found out the bad surfaces, and I would have put them into this alternate track table. And typically I would look at the defect list on the front of the drive, but I wouldn't rely on it. I would actually rely more on spinning the drive up for a few hours, doing the read-all, and then mapping that into the alternate track table. Okay, I hope you've learnt something, and this drive is going to be going to Pastors New soon, and when it does, I hope it will actually start to work for a living. Okay, thanks for watching, Darry.